The tunnel you're seeing is not an ordinary tunnel. It is, in fact, the world's largest tunnel that literally passes under the sea. This 50-kilometer-long tunnel is that megaproject which engineers call the seventh wonder of the world. The main reason for this is its construction, working with 13,000 workers altogether in extremely challenging conditions and excavating a part of the ground upon which the weight of the whole sea is bearing down. One small mistake can fill this tunnel with water and can bury both humans and machines forever. And that too in just a few seconds. Welcome back once again to Discover TV's videos. Viewers, about 13,000 years ago, when the last ice age was coming to an end, it separated today's England and Europe from each other. The reason for their separation was this part of the sea, which is now called the English Channel. Although this channel is quite wide, it becomes quite narrow at this point. Here, England and France are only about 33 kilometers apart. Many times in history, attempts have been made to bridge this gap, but these experiments were stopped after many lives were lost, perhaps because the technology was very limited at that time. By the end of the 20th century, as technology advanced rapidly, the idea of connecting England and France by land resurfaced. It was the era of the 1980s when larger machinery became feasible. Apart from the machine, there was another challenge to convince England. Yes, the cold waters of the English Channel had always given England a strategic advantage over its enemies. From Napoleon to Hitler, many of England's enemies planned to capture it, but the harsh conditions of the English Channel always gave England the upper hand. During World War II, Hitler, from a village called Calais in France, launched a secret project to dig an underwater tunnel to gain control over England. However, this project was never initiated. After Hitler's death and World War II, significant changes occurred in Europe. Business started booming and prosperity spread. France and England, once enemies, began trading through the English Channel. As time passed, in 1986, both countries decided to remove this barrier and connect England with Europe. However, many protests erupted in England against this decision because many people took great pride in England's island sovereignty. After several months of long talks, both countries finally agreed to build an undersea tunnel. It was named the Channel Tunnel, which many people refer to as the Eurotunnel. It was agreed that teams from England and France would dig the tunnel from their respective sides, and both tunnel segments would connect at the center points. The project looked like a colossal failure even before it started. Constructing a tunnel approximately 38 kilometers long beneath the sea was not a task any engineering firm would dare to undertake. Eventually, it was decided that 10 engineering firms would collaborate to construct the project. Before finalizing the design of the Channel Tunnel, it was essential to determine which type of transport would run through the tunnel and where it would start and end. Through mutual understanding, it was decided that a total of 3 tunnels would be built, with a railway loop running between England and France. One terminal would be in the French city of Calais, while the other would be at Folkestone in England. The total length of the tunnel would be 56 kilometers, with 38 kilometers of it running underwater. Finally, in 1986, construction of the Channel Tunnel began. The biggest challenge the engineering team faced was the tunnel boring machine, also known as TBM. Before this, no project of this scale had been attempted, so a TBM of the required diameter was unavailable. The machine had to be built from scratch. Thousands of miles away in Seattle, Washington, the Robbins Company was commissioned to build this tunneling machine. The company specialized in making boring machines. Once completed, this gigantic machine would be 800 feet long, weigh 1,500 tons, and have a 50-foot diameter with multiple sharp-edged blades made of tungsten carbide at its front. The hydraulic legs attached to the machine would push it forward, and a conveyor belt inside would remove soil and crushed stones, carrying the debris to a service train, which would then transport it out of the tunnel. This tunnel boring machine was a marvel in itself. Unlike the old technique of blasting mountains to build tunnels, this machine was a significant breakthrough for developers. However, this technology also introduced many risks and challenges. If water leaked during the 250-foot deep underwater boring, the pressure would be so high that it could drown both man and machine in seconds. A survey revealed that there was a layer of chalk beneath the seabed on the England side, which would prevent water leakage into the tunnel. However, on the French side, there were many cracks in the seabed, rendering the TBM ineffective. A separate TBM was designed to address this issue, doubling as a submarine to withstand extreme water pressure, similar to World War II submarines. When this machine was developed, another challenge arose: how to transport it 200 feet below the ground. The machine was disassembled, and each piece was separately taken down, where it had to be reassembled underground. This process took several months and cost millions of dollars. 2 years after the project began, construction finally started on both sides in 1988. Disposing of the large quantity of soil and rock debris was a massive challenge. The machine cut 750 square feet of stones daily, accumulating about 2,400 tons of debris every hour. On the English side, the debris was used to create a country park called Samphire Hoe under the Shakespeare Cliff between Folkestone and Dover, causing it to slightly protrude from the coastline. The debris from the French side, in the form of mud, was used to create an artificial lake in the Fond-Pignon Valley near Sangatte. As the TBM progressed, sealing the loose rock and chalk layers was equally crucial. If seawater found a way into the tunnel, stopping it would be impossible. Round concrete slabs, stronger than those used in nuclear plants, were fitted to reinforce the tunnel. About 750,000 concrete slabs were used in the tunnel, each weighing 40 tons. In total, the concrete used in this project could build 8 buildings the size of the Burj Khalifa. Weeks turned into months as the tunnel slowly progressed from both sides. Everyone eagerly awaited the moment when the two tunnels would finally meet. Though it might seem simple, aligning the two T-beams perfectly under the sea was incredibly complex. To ensure accuracy, a laser beam guidance system was used. A laser was installed in each machine, wirelessly connected to send signals whenever a position adjustment was needed. As a final check, both machines were shut down in the last 100 meters, and a steel rod was sent through to confirm their alignment. After 3 years of continuous boring, the moment arrived. Only 100 meters remained. The steel rod was sent, and the tunnels were almost perfectly aligned, with only a 10-inch difference, which was within the allowed limit. Now came the biggest challenge. One of the T-beams had to be sacrificed. Because 2-foot-thick concrete slabs had been installed in both tunnels, the tunnel diameter had reduced from 50 feet to 46 feet. A 50-foot TBM could not fit back through a 46-foot tunnel. To solve this, the English TBM was tilted downward and buried underground, where it remains to this day. With the final phase complete, the French TBM moved forward and connected with the English tunnel. It was then dismantled and removed. You might wonder why the English TBM wasn't also dismantled. The reason was cost. Disassembling it was as expensive as building a new one. Engineers always evaluate whether burial or removal is more cost-effective. In this case, burial was the better option. For the first time in 13,000 years, a land connection was about to be re-established between England and France. 2 workers, one from each country, were chosen to manually break the last layer of chalk with a jackhammer, and for the media event, they exchanged flags. After being separated by glaciers thousands of years ago, England and France were finally reconnected. It was a historic achievement, celebrated with grandeur. After years of hard work, the effort paid off. Following the final finishing touches, the Channel Tunnel officially opened on May 6, 1994. Adjusted for today's currency, the project cost £12 billion, equivalent to 1,190 billion rupees. At its peak, around 13,000 workers were involved in the project, while 10 lost their lives due to accidents. The tunnel consists of 3 sections for trains and 1 smaller emergency tunnel. Today, around 60,000 passengers use the tunnel daily, including 4,600 trucks, 140 coaches, and 7,300 vehicles transported via cargo trains. I hope you will like and share this video of Discover TV. Thank you so much for your kind comments. See you in the next awesome video.